Addy leads Google Chrome's developer experience organization. I'm pretty sure he got promoted also recently, which is like, how can I get promoted from working in Google Chrome? But, you know, he demonstrates how giving AI models structured access to browser runtime is going to eliminate guesswork and reduce hallucinations. That's his presentation. We're going to look at it from a perspective of, here's a coding agent, here's a problem that requires a specific type of tool. And folks, if you've used the Chrome DevTools MCP, you know it can be extremely useful for a lot of scenarios as a web dev, as anyone building an application with a coding agent. So push the video by Addy, and then we'll do a little appraisal of it before we go into the next video.
Hey folks, my name is Addy Osmani. I work on developer tools and AI at Google. Today we're going to talk about the Chrome DevTools MCP and how it can vastly improve the context for your AI coding workflow. This is a bit of a game changer. Now, context engineering is the art and science of filling the context window with just the right information needed to guide an AI agent's performance. Now, if you're a web developer, you probably spend your time in a few core tools: your code editor, the browser debugger like Chrome DevTools, and other tools like source management. Your code editor probably has a source code view and an AI assistant. Now, AI is rapidly transforming how we're building for the web. Anywhere up to 90% of us are using it to code, but conservatively, devs are seeing a 10% or greater increase in velocity because of it. Now, on the flip side, trust in AI-generated code accuracy is surprisingly low and declining. Now, there's a lot that we can do here to help because there's often a lack of context. So what exactly is context? What is context engineering? It means equipping an AI agent with everything that it needs: the data, the tools, the history to tackle a task effectively. Not just a clever prompt, but the full setup. Now, this shift is kind of crucial for agentic systems that act autonomously. Now, that context can include a spec, task context, background data, examples. You can include visual context, things like screenshots, whenever you're asking AI to create designs or fix bugs, but there's still a very big piece missing. So back to your workflow, you're probably not giving your AI coding agent all of the context that it needs to be successful today. For example, AI assistants can't see the app that is running in the browser or any of the runtime information. It can't see what gets rendered, that runtime data, the errors, the logs. So there's a big piece there missing. This is where Chrome DevTools MCP comes in. It enables AI coding agents to see, debug, and optimize in real time with rich runtime context from the browser. Let me show you it in action. So let me show you a demo of the Chrome DevTools MCP. This is our new MCP server, which allows your coding agent to control and inspect a live Chrome browser and have the full power of DevTools for debugging. So here I've got a movies application, and it loads a little bit slower than I'd like. So I'm going to go to VS Code, and I'm going to use the new Chrome DevTools MCP to find and fix performance issues. For example, so if I go to my MCP servers list in Client, which is the AI coding plugin that I use Client. I have my Chrome DevTools MCP here, and I can see that there are a number of different tools that are available. These are really automated versions of tasks you might complete yourself. So I'm just going to go over to my chat here, and I'm going to say, well, localhost 3001, where I've got this running, is loading slowly. Make it fast. So that's all I'm going to do, high-level prompt, and let's see what happens. So this is the next JS application we're using, and so we're going to be using Chrome DevTools MCP to make it faster. So it's firing up an instance of the browser. We've got our app running here, and now that it sees the page is open, it wants to run a performance trace using our MCP server. So awesome. Now this is going to act a lot like a performance expert. You know, the performance expert would run a performance trace, they'd profile, and they would look at metrics, right? So here it's returned a number of metrics, and it started to kind of do breakdowns, get some insights. And what I can see is that the performance trace is now complete, and it shows some areas for potential improvement. Like the largest contentful paint could be better. There's some loading delay. So now it's going to analyze these insights to get more detailed breakdowns. So the analysis reveals that there are some opportunities for improvement here. There are some bottlenecks. So I'm just going to go ahead and approve that so we can look at the LCP breakdown. And what it confirms is that the loading delay is the primary cause here. Maybe it's due to the movie posters. So the priority of the network request for our images is set to low. That's a strong indication the images being maybe lazy loaded, isn't being prioritized correctly. So in our movie card component, we're going to use the priority prop on the image component to fix this issue. Okay, cool stuff. So that's going to be using fetch priority under the hood, I believe. Awesome, awesome. So it's implemented the optimization already, and it just wants to verify that it's improved performance. So now it's going to navigate to the page again. We've already made those fixes. Everything is working great. So now let's verify. Let's see if there's actually been performance improvements made. So now the LCP has improved from 280 milliseconds, but low delay is still kind of there. The largest contributor indicates that maybe the image is not being discovered easily. And so it's going to do some further analysis. It can continue to help us find opportunities to improve. And it's already improved the performance of this page, so that's great. We can continue to use this. This is really just an example of many of the things that you can do. So here it's going to modify the index to make sure that it's preloading the right images, that the LCP is discoverable in our HTML. And these are just insights that you would expect a performance expert to be diving into, your code base and figuring out. They'd be looking at traces, they'd be diving into flame charts or network requests, and any of these other things to be able to have this automated for you as a part of the Chrome DevTools MCP offering is just really, really awesome. So I hope you're going to go check it out. This is helpful for everything from fixing layout issues to fixing performance issues. If you've got errors or warnings in your app, it can help there. This is really just giving you all that rich runtime context for the browser so you can improve the chances that your AI coding agent is going to be able to fix a lot of these issues for you. It's really awesome stuff. Let me show you some more demos in action. This demo is about emulating devices and debugging styles. So we're going to use Chrome DevTools MCP to automatically debug styles across different device sizes. So what this demo shows is a website, the DevTools Times, which has a cutoff navigation menu on Pixel phones. The coding agent, so Claude Code in this case, navigates to the page running on a local development server. Then it changes the window dimensions to match the dimensions of a Pixel phone. The coding agent takes a screenshot of the page and discovers that, as prompted, the first menu item is cut off. This coding agent analyzes the source code and updates the CSS to address the bug. And it applies the change to the code, it reloads the page, and it just verifies via screenshot that the problem has been fixed. Now this is awesome. It shows that you can use DevTools MCP to automatically take screenshots to analyze the visual appearance of the page. It's really good stuff. Here is another demo about form submissions that might be failing. So for example, in this demo, we're showing a registration form that doesn't work when the user tries to click register. The coding agent navigates to the page running on a local development server. It fills out the form and clicks register. It debugs the form failure by looking at the console output, which includes an error message from the server. From the error message, it learns that the server expects form data send to be JSON. So the coding agent applies the fix, tests the form again, and it works. So what's cool here is that the coding agent is automatically generating dummy test data to fill out and test the form, in addition to just helping you generally fix all of these issues. It's really great stuff. So with our demo behind us, just a quick reminder, Chrome DevTools MCP gives your AI coding agent eyes, so it has the context needed to solve many problems. It's free to use. You can go and check it out on our GitHub repo. We hope you'll find it useful. It's relatively quick to get it set up. Now remember, it's not the prompt, it's the context. Quality context determines if your coding agent is going to succeed or fail. Start applying things like the Chrome DevTools MCP today. I think your AI coding agents might thank you. Thanks for your time. I hope this was helpful. My books and more free content are available on my site. Cheers.